How do they build underwater tunnels? Building underwater tunnels is one of the most impressive feats of modern engineering. These tunnels connect cities, countries, and continents, carrying vehicles and trains safely beneath rivers, lakes, and even seas. But how exactly do engineers accomplish such an incredible task? From design to excavation and sealing, underwater tunnel construction involves a combination of cutting-edge technology and precise planning. Let's explore the methods, challenges, and innovations that make underwater tunnels possible. 1. The concept. Why build underwater tunnels? Transportation and connectivity. Underwater tunnels provide a continuous, direct route between distant or isolated locations, often providing a faster and more direct path than bridges. Environmental and practical concerns. In busy urban areas or in regions with large rivers or bays, underwater tunnels reduce the impact on waterway traffic and maintain the landscape. 2. Methods of underwater tunnel construction. A. Immersed tube tunneling, ITT. Process. Prefabricated sections of the tunnel are built on land, floated to the construction site, and submerged into a pre-dug trench in the waterbed. Once placed, the sections are connected, sealed, and covered with fill to stabilize the tunnel. Advantages. ITT is popular for building long tunnels, especially for shallow waters, as it's generally faster and more cost-effective. Examples. The Marmara Tunnel under the Bosphorus Strait in Turkey and the Channel Tunnel between England and France were both partially constructed using ITT. B. Bored tunneling, tunnel boring machines, TBM. Process. A giant tunnel boring machine, TBM, cuts through soil and rock while creating a tunnel lining as it advances. This method is used when tunnels are built deep below the surface. Advantages. TBMs are ideal for tunnels under deep waterways or densely populated urban areas where disruption to the surface needs to be minimized. Examples. The Tokyo Bay Aqua Line in Japan was constructed primarily with TBM technology to avoid disruption to one of the busiest waterways in the world. C. Cut and cover method. Process. In shallower waters, engineers use the cut and cover method, where they dig a trench, place the tunnel within, and cover it back up. It's simpler but mostly used in shallower areas close to the shore. Examples. This method is frequently used for short distances or shallow tunnels, such as the approaches to deeper tunnel sections near shorelines. 3. Addressing engineering challenges. Water pressure. As the tunnel goes deeper underwater, the water pressure on it increases. Engineers use reinforced materials like concrete lined with steel to create a strong, watertight structure that can withstand intense pressures. Sealing and waterproofing. Every section of the tunnel must be sealed tightly to prevent leaks. In immersed tube tunnels, rubber gaskets or concrete grouting are used at joints. Bored tunnels require a specially designed lining to keep the water out. Ventilation and lighting. Underwater tunnels must have a reliable ventilation system to keep air fresh and prevent the buildup of vehicle emissions. Lighting is essential to ensure safety, and many modern tunnels use LED lights and emergency systems. 4. Safety measures. Emergency exits. Underwater tunnels are designed with emergency exit pathways in case of an incident. Water pumps. High-capacity pumps are installed to remove any water that might seep in. Structural monitoring. Sensors continuously monitor the structural integrity of the tunnel, alerting engineers if any part of the tunnel shows signs of stress or damage. 5. Notable underwater tunnels around the world. Channel Tunnel, Eurotunnels connecting the United Kingdom and France. This is one of the longest undersea tunnels, stretching over 37 kilometers beneath the English Channel. Tokyo Bay Aqua Line. This tunnel bridge hybrid is a marvel in Tokyo Bay, consisting of a 9.6-kilometer tunnel section that emerges to a bridge. Seikan Tunnel. Located in Japan, it's the world's longest and deepest operational tunnel under the seabed, reaching a depth of 240 meters below sea level. 6. Future innovations in underwater tunneling. Robotics and AI. Robots are increasingly being used to conduct inspections and repairs in tunnels where humans cannot go. New materials. Engineers are exploring composite materials that are both stronger and lighter than traditional steel and concrete, reducing costs and making construction safer. Building underwater tunnels is no small feat, involving a mix of cutting-edge technology, skilled engineering, and careful planning to navigate the unique challenges of underwater construction. As technology advances, underwater tunnels may stretch longer, go deeper, and connect more locations around the world, making global connectivity even stronger.